This is CCS America's series Let's Talk Lighting, where we discuss machine vision lighting techniques and technology so you can solve lighting challenges more efficiently in-house. I'm Emily Ting, marketing specialist at CCS America and co-host of this series together with Lindsay Sullivan, our technical marketing manager. And this time we have a special guest with us. We have Max Tuszynski, who is the sales and applications engineer at CCS America's sister company, Gardasoft. So, Max, thanks for joining us today. How are you doing?
I'm doing well, thanks. Thanks very much for having me. It's a pleasure to be here.
No, we're excited for, special guest number one in the history of this series. So, a special place for you.
Going down in the history books, I like it.
Exactly, history maker. Do you want to first start out by sharing a little bit about what you do at Gardasoft?
I'm a sales and applications engineer. My background is all technical, and the sales stuff is new to me. My job is basically to talk to you guys and help you work out what products your customers need, and yeah, make sure everyone's buying the right things.
That is basically what our job is here on this side as well. But we focus more on the lighting itself, and you are, or Gardasoft specialize in lighting control. And the reason this, history making episode came about was Max joined our annual kickoff this year. And while he was here, our president went through some role play with him to illustrate some challenging applications where Gardasoft controllers are a really great solution. And it was a great learning experience for the whole team. So we thought we'd try and recreate it here to give that same value to our audience. So looking forward to it. Before we get into the scenarios, I thought we could do like a basic 101 into the electrical engineering involved in lighting and lighting control, just so people listening have a good foundational level of what's going on beneath the, in the circuits and all that stuff.
Yeah, sure. Um, yeah, I suppose there's a few important things when we're thinking about sort of lighting control, things that we're thinking about. And none of it is too complicated, really. At a basic level, we're looking at sort of the relationships between the voltage, the current, and the power in a light. And that's a simple equation. It's just voltage is current times resistance. And there's a really good analogy to think about these things if you're thinking about like a water environment. So voltage in a circuit is about the same as water pressure, and current is very similar to like the flow rate. So one is sort of pushing things through, and the other is how much of it is flowing. Those become very important when we're thinking about the controllers we're using and the lights that we're driving and how much we're driving them as well, especially when we're overdriving, which is Gardasoft's specialty. That was kind of the whole reason the company came about. And a lot of what we do is overdriving those lights.
Nice. So is that why Gardasoft focused on controlling the current? Because the current is better for overdriving?
Yeah, so the main reason we focus on current is LEDs are current-driven devices, basically. So the current that you're sending through is directly proportional to the light output, the lumens you're getting out of the light. So if you were to look at the relationship between voltage and current in a light, you get sort of there's a J point somewhere, and suddenly it goes off exponentially. So when you're operating over that J point, that's if you were to have a very small increase in voltage, you would see a very large increase in current and output. So if we control that current instead of the voltage, we can much more tightly sort of control what the output of that light is. It becomes a lot easier to manage that.
Okay. So, but for CCS, we do voltage driven. So like when we give our information, probably 90% of our lights, Emily, are going to give the, 24 volts and 120 watts or something like that. So it's not giving the current value, but we can work with current controllers So can you kind of expand a little bit on, CCS doesn't need a current controller, but it still works with one, and what's, the difference between the two ratings that we
Yeah,
get?
sure. So as I understand it, all CCS lights are sort of, most of them will work at, for example, 24 volts. And the way CCS achieves that is by using resistors in series inside their lights. So what you're relying on there effectively is Ohm's law, which is the relationship between current, resistance, and voltage. And you're saying at 24 volts, I want this amount of current to be going through the LEDs, and you size the resistor properly to make sure that at 24 volts, you're getting exactly the output you want. If we're using a current controller, we don't need to worry about what the voltage will be doing, because as much voltage as is needed will flow through the light to achieve the current that we're asking for. So there's a slightly different approach there. As you say, for CCS lights with a CCS controller, if you ask for, it will give the output that you want at 24 volts that you're asking for. So it depends on your application as to what you need. For the Gardasoft stuff, we think about current, and we don't really mind about what the voltage is doing as long as we know what the current is.
Okay. So kind of just to maybe summarize, make sure that I'm understanding it and, it's clear. A CCS light will have like a resistor in it that's properly, mediating when it needs to mediate, so it can work with the voltage controller or current controller. So those lights will be like 24 volts, whatever watts. But if there's ever a rating that just gives like milliamps or something like that, that cannot work with the voltage controller. That has to be done with the current controller, which could be Gardasoft would be a great option for that. And then your controller would properly control the current so it doesn't like overflow or break the light.
Yeah, exactly.
By giving it too much, right?
And what you would find is with those voltage-driven lights that you're finding with the resistors in them, if you were to use a current controller on one of those, you would probably find that the voltage that it needs to achieve the current is that 24 volts that the regular voltage supply could give. So in controlling that current, we kind of make sure that we can do both ways. We can supply the current that's needed, or we can we'll always supply the current that's needed. And if that voltage is the same, great. And if not, we don't mind so much.
Perfect. Yeah. So you just calculate what the current is based on what you're given, and put it into the controller for Gardasoft, and you're working great.
Exactly that. Yeah.
Nice. Awesome. Thanks for that intro. That's nice to get all the terms.
Yeah.
Everyone throws a lot of terms out, and if you don't know what they are, you get really lost really quickly.
Yeah. No, it's.
Feel like
It took me by surprise when I first joined. So I've only been at the company about a year now, but there was a bit of a learning curve, and it is scary when you come across it. But the more you work with it, the better it gets, I think.
you did a great job, Max. If you had been my high school physics teacher, I feel like the electrical physics portion would have gone a lot more smoothly for me. That was where I tanked in high school physics. Everything was fine until then.
Also, you say you've only been here for a year. It feels like it's been at least 2.5. Like, I don't know if I believe you.
I barely passed my high school physics. It took me a long time to get my head around this stuff.
Could have fooled me.
Yeah.
Talking about the challenges of all this stuff, I think something I've noticed a lot since I've been in CCS, which is, probably a lot longer than you've been at Gardasoft, but controllers are always the area that seems to intimidate customers the most, whether it's CCS controllers or Gardasoft controllers. It's like, it's too intimidating. They'd rather just like skip it and just plug it into the wall and be done with it, not even think about trying to choose a controller. So do you want to kind of expound on why is it so intimidating? Why is it maybe not so straightforward or intuitive as we'd like it to be?
Yeah, sure. I think there is a bit of a stigma around the controllers, like you say. And I think it's because we have to get into the nuts and bolts of it a little bit. We're kind of solving the whole electrical system. It's not just sort of the lighting output. You need to think, it's a multivariate issue. And you need to think about all sorts of different things to make sure you're getting the right controller for the right application. And it's the things that you need to think about are how fast you might be pulsing it, how much you want to overdrive, what kind of light you're using, what kind of temperatures you're running at. It's sort of all of these components sort of play a part in the decision, and it can feel like there's just so much to worry about at the beginning. But Gardasoft have been doing this for 20 years now, 25 years even, and we're getting quite good at sort of a formulaic approach to it and sort of nailing down all the problems and all the thoughts, and just getting it out of the way. So I think going back to your main question, then you have to think about a few different things to work out what the best controller is for the application, and that can be scary. But Gardasoft are here to help, and of course, if you need some help with it and you're not sure what you're doing, we're always there to help and help you work out what you need to know and guide you through it.
And that's basically what we're going to be doing today. We've got a couple of scenarios, and I think some of them were from the actual role play that you did. And our president chose some good ones, some challenging ones. So we'll get right into the first scenario, which is, we have a customer who wants to overdrive, let's say, one of our ring lights, the LDR2 120 SW2, by 6 to 7 times its intensity. Which controller would you tell them to use?
Okay. So there's a few things I want to know about this application before telling them the control. So like I say, it's a multivariate issue. So we have the part number of the light there. What I'd like to know first, because I'm not so hot on CCS part numbers as you guys are, I'm sure. So what kind of voltage and current are we looking at in this light? What kind of power is it driving?
24 volts, 26 watts.
Okay. So that tells us then, if we're trying to think about the current in that, like I say, there's a relationship between power, voltage, and current. And if you want to get the power, you just times the voltage by the current. So we're looking at just a little bit over 1 amp here, which means we're not looking at an awful lot of power in that light. If we want to overdrive it by 6 or 7 times, we're going to be looking at 6 to 8 amps or something like that. So that's very doable. We can probably manage that. Are we just looking at one light, or are there going to be a few different channels to think about?
Oh, just one channel.
Okay. So that makes it simpler. It means we can choose one of our smaller controllers. Our controllers come in sort of.
Hi, Max.
Oh no.
An unknown error occurred. Please try again.
There he is.
Hear me now.
Goodness, they're not.
He's
Max!
Nice to see you again.
Yeah.
Very sorry about that. I don't know what happened.
Oh, it's all right. It's not our first encounter with tech troubles, as you know, and I've had this plan in the back of my mind, for not necessarily this very scenario, but for something to go wrong. In my mind, it was going to be because of Lindsay's kids interrupting the meeting, but this
For the record, I did lock the door, and they did try and come in at least once already.
I could hear the cries of children in the background that I'll have to cut out.
Leave them in.
Well,
It's real.
it wouldn't be a debut if it went completely smoothly, would it?
No.
So
We
before
were joking around that it was an electricity problem, and I was like, we should have been able to solve this. That's what we're telling everyone.
Yeah.
Where were we actually?
So we were talking about the controller to use for your application, trying to overdrive 6 or 7 times, I think.
Yeah.
Yeah. So where we got to, we were saying
You were
6 or
talking
7
about
times
the
would be
relationship between 1.2 amps. We can use a smaller controller. I think that was the last thing you said.
That's right. Yeah. So we've only got one channel to worry about. So we can use one of our smaller controllers that doesn't have many channels. We have controllers in 2, 4, 8, or 16 channel variants, depending on the series you go for. One of the two, even one channel as well, but I think we'll use one of the 2 channel controllers for this. That gives us a little bit of extra headroom, and we can use that to drive this. If you're overdriving, you're going to not be able to run the light continuously all the time. So we're going to be pulsing that light, basically. Do you know how often you're going to be, or how long you're going to be wanting to pulse this for, sort of what the pulse width will be?
Lindsay, what do you think we should choose to make this as hard as possible?
Let's do like
Thanks.
5
Thanks very much.
milliseconds. Yeah. Let's do 5 milliseconds.
Okay, 5 milliseconds isn't too bad. So yeah, in this application, then I think we would be looking at an RT controller, probably the RT220, and the -20 variant will do this for us. So let me break that down then. So the RT is the series of controllers, sorry, and the 220 would be the 2-channel version, and then that -20 at the end means that this will go up to 20 amps, so it's 0 to 20 amp controller. The other variant type we have is a -2, which goes between 0 and 2. But if we're trying to overdrive to 6 or 7 amps, that's not going to cut it. So let's use the -20. We don't need to use many channels, so that's the 2-channel variant, and the pulsing isn't especially fast, so we don't have to worry about choosing something a bit more, a bit quicker, like maybe one of the PP series. This would do our job just fine. It's probably worth mentioning that this light might be a little bit easier to drive at 6 or 7 times if we take some of the resistors out of it. So I remember you saying earlier, Lindsay, that the CCS lights have resistors in them so that they work at 24 volts. If we can take that resistor out, it would no longer be working at 24 volts, but there's less resistance in there that we have to overcome in order to drive sort of the current we need. So that might be a good step if we can do something like that, but not essential in this case.
And that is possible to do, right? So if you do have that situation, person listening, you would just ask CCS, can I get a custom light with the resistor removed? And we would, ask all these questions that you told Gardasoft, and they would build the light and make sure it all works together. So that is definitely possible if you need a little bit more intensity to do that. So a lot of times when we're talking about controllers and overdriving, especially, the duty cycle comes up. You didn't ask that question though when you picked a controller. So when do you have to know the duty cycle? When do you not have to know it? And can you go into what the duty cycle is?
Yeah, that's a good point. So as I was saying earlier, when we're overdriving a light, we can't leave it on all the time because it would get too hot and burn up and die. We don't want that. So
it's gonna burn up and die.
Well, we don't want that to happen. So what we do, the controllers will limit the duty cycle effectively. Most of our Gardasoft controllers have inbuilt technologies that will see how much you want to overdrive the light by, and it will limit that duty cycle so that you can't damage the light yourself. What we mean by duty cycle here is on time of the light. For example, if you had a period of 1 second and a duty cycle of 100 milliseconds, you would an on time, a pulse width of 100 milliseconds, you would have a 10% duty cycle. So like I say, what we want to do is limit that duty cycle so that the average power going through the light never exceeds the sort of continuous rating of that light. And yeah, Gardasoft controllers, most of them will prevent you from damaging it by imposing limits on that. It can become a problem when we're thinking about the PP series in terms of heat dissipation. But for the RT series, it simplifies this, and the controller will stop you from damaging the light yourself.
So if you were to put in like something that, like a pulse width that would make the duty cycle not possible, the controller would just like change the pulse width to be the like max that it can be.
Yeah. So if you're saying I want to overdrive this light by 6 or 7 times, and then you input a pulse width that is too high, what these controllers will do is they won't let you do that, but instead they will input the maximum that they think is safe, so that they make sure that they give you as much as they can give you without damaging the light.
Okay. I've always described the duty cycle as like the lights on time versus the rest time, and like making sure it doesn't get too hot was always the way I focused on it, which you mentioned with the PP
exactly
heat dissipation and all that jazz. So it's nice. I like using the RTs because I just don't have to like think about, am I doing it right? Did I miscalculate or fat finger it even?
No, exactly. That's the benefit of the RT controllers, is that they are pretty much configure it and then don't worry about it because it's there to look after you. And we've got the technologies in place that are going to stop you from damaging your system. The PPs can be a little bit more performant, especially if you're looking to do things a little bit more quickly. But we do have to start thinking about the heat dissipations. And that's not as scary as it sounds, but if you just want a solution that's fire and forget, then the RTs are what you want to go for.
So I have a quick question, pivoting away from duty cycle. So a lot of times when we're overdriving light, we say we give it 48 volts, but CCS puts a resistor in that does 24 volts. So what's happening with the 48 volts that we're driving, but the resistor and the light, if we don't customize it and take it out, like are we just limiting it to 24 volts anyway? Can you kind of?
Yeah, sure. So yeah, we might not, if we're overdriving, for example, if you're overdriving with a voltage controller and you go between 24 and 48 volts, that's two distinct levels, isn't it? So if you're using a Gardasoft controller, you're not necessarily wanting to use those two levels, like 100% or 200% of the voltage. We can overdrive usually up to 10 times the rating of the light is what we'll allow you to do. And of course, that comes with its own, as your overdrive level increases and increases, the restrictions on pulse width and duty cycle will come down and down. So that's again preventing that average power from getting too high. If you're as a Gardasoft controller, you might not be using 48 volts then to overdrive. It could be somewhere above 24 volts, which is the operating point normally. But if it doesn't need 48, it won't do 48. And if you're trying to overdrive it that needs a little bit more than that, then it will use a bit more than that.
Okay. Perfect. I think that's all the questions I have on, what do we need to know for this scenario? So you would recommend the RT220. Do we need the fast version? Some of them, is it the RTs that have the F at the end?
Yeah. So there are some of those. So the difference between those, I mean, they are the same package size, but the Fs are a little bit more performant. They're slightly quicker. So I think off the top of my head, you'd have to double check the spec sheets on these, but the standard non-F variants are good for about 800 hertz on a trigger sequence. So you can do 800 triggers per second, and the F variants will go up to 1 kilohertz, so 1,000 triggers per second.
Okay. Wow. So we
The
would not need
PPs can
faster.
go, not in this case, no. The PPs can go a whole lot faster than that as well. But as I say, you've got to start thinking about the power at that point and the heat.
No, awesome. All right, Emily, you want to do the second scenario?
This time the customer wants to use a light that's 50 amps. What controller should they use?
Okay, so 50 amps is quite a lot of current to be pushing. I'm assuming they're going to be pulsing this to achieve that. So it could be that we have a few solutions for this. The easiest solution might be a HT. That's sort of the most plug and play option, but we could do it a few other ways depending on what speeds you need and sort of how many channels you want. So we could be using a PP8 or a PP16, which are our high channel count controllers. So I'd say, yeah, a big question would be how many channels are you wanting to use here?
To make it harder on you, let's say 2 channels.
Okay, so 2 channels.
Actually, it's probably
up to
making
2
it easier
channels.
on you. It would be 2 channels.
Up to 2 channels, I would recommend the HT controller. It's got the same sort of protections as the RTs, where it just looks after you and you don't have to worry about it. So that would be my solution for that.
So if we did
you want
3 or more,
3 or more, then you're making it difficult. Then if you want to do that in a single controller, I'd be looking at a PP8 or a PP16. And what we can do with those controllers is actually combine a few channels into one light. So a PP8 or a PP16, the right variant, will have a maximum of 20 amps per channel. But if we use, say, 3 channels, and or let's make the maths easy. Let's say, what would make the maths easy for me? If we use 4 channels and we do 12.5 amps down each channel, we could then have, pull 50 amps through that light, but do it through multiple channels on the controller. And what we would do is configure each of those channels to respond to the same trigger signal so that it's pulling all of them at the same time. And that way we could drive the light much faster. We would then have to worry about the heat calculations, but we can worry about that in a minute. And with that, we could go up to probably around, I think, 30 kilohertz with the PP controllers.
okay. So so if we were doing on 30 hertz, we would not do the HT, even if it was 2 channels, And 30 kilohertz, could we do the HT, or would that have to be the PP?
That would probably have to be the PP. So the HT controllers will go up to about 15 kilohertz per channel. So that can be a limitation on that as well. Someone's going to play in your head.
That's me. I live close to a little mini airport. Tommy's always like, airplane.
Oh,
It's a good microphone,
I
my
still do
goodness.
that. Yeah, I do exactly that every time one goes over. It stops all work. Have to work out what it is. What were we saying? Sorry, yeah. So the HT controller is only really capable of going up to 15 kilohertz. It can do that on both channels at the same time, but 15 kilohertz is its limit. So if we wanted to go faster than that, say if you had a 30 kilohertz application, then you'd be looking at the PP series as well. That might be a factor.
Okay. So if you were going to pull four channels to do the 50 amp light and you needed 2, you would have to use a PP8. And if we were doing 3, then we would have to use a PP16 because we're like out of channels. And that's how you would kind of like pick between.
Yeah, that's how it would work. So for in this case I gave, I can't remember how to divide 50 by 3 at the moment because it's a Friday afternoon for me.
Right.
But you could do 50 amps into 3 channels on a PP8. So yeah, you could drive 2 lights at a time, and then you run out of channels. If we wanted to use more than that, we'd have to use a PP16 where we have double the channel count and we can drive more light with one controller.
Okay. Is there a scenario where you can't dissipate all the heat enough and you just can't solve the application? Does that happen?
It can happen, but we try and find ways around that. So it depends on how many requirements are absolutely fixed by the application. So there are things we can do that will help with dissipating heat. One of them could be maybe reducing the power supply voltage, and that will decrease the amount of heat that we have to dissipate in the controller. Other options could be heat sinking the controller or using some kind of active cooling like a fan. That can make a massive difference straight away, and it's a bit of an easy win. So I would say, yeah, there are applications where there is just too much heat and you can't fix it, but there are a lot of things we can do before we get to that point to mitigate that and sort of help solve the solution.
Nice. And then we used a lot of terms that we didn't really go through in the beginning. When we say like 30 kilohertz, what do we mean by that? Can you just clarify?
Yeah, sure. So what I'm meaning when I say 30 kilohertz in the controller environment is that 30,000 triggers every second. So yeah, 30 kilohertz is the rate. And what I'm expecting there is those will be trigger signals that we get into the controller. And every time you get a trigger signal, you want to flash the lights on for a very small amount of time. So 30 kilohertz is pretty quick to be sort of flashing lights, but we're seeing more and more as applications are evolving. People want to go faster and faster, and it's becoming more common to see these sort of high frequencies for application.
Mm-hmm.
Sorry, non-expert question here. What? Can you explain trigger signals? I feel like this time I'm really showing how much I don't know about anything.
That's fine. So all of our controllers are usually triggered by what we call a trigger signal, and that will be a logic level signal that's coming from something that's triggering the light. So that might be a smart vision camera, it might be a PLC, it could be some other hardware that someone's got wired in.
Like a sensor.
And a sensor, exactly. And what the controller will be looking for will be a logical one, which I think off the top of my head is somewhere over 3 volts. And it's looking for the change from low, which will be less than 1 volt, to high, which is more than 3 volts. And when it sees that change, that's what it declares to be a trigger signal. And it will use that to trigger. You can invert that as well if you like. So you can invert the triggers and say, I want you to only trigger when you see it fall from 1 to 0 instead of 0 to 1. So those being sort of binary positions. So 0 being low, 1 being high.
Is it NPN when the signal's high and drops, and PMP when it's low and rises? Is that, I always confused them.
That depends very much on the context. I think, to be honest, I'm not entirely sure.
I think so.
I think so. Someone will tell us if we're wrong.
They will.
The best way to get an answer is,
Just get a heated comment. at the bottom
Yeah.
of our
As
video.
someone told me that's the
PNP
best way to
memes.
get an answer. Yeah. Find the right answer on the internet by posting the wrong answer and someone will correct you.
Yeah.
Life hack for you, everybody. Brought to you by Max.
Yeah. I'm not sure if I want that one to my name, but anyway.
Well, too late now.
Yeah, so if it's like if it's 30 kilohertz, does that mean it's receiving, like it can receive 30 triggers per second, or it needs to receive 30 triggers per second?
Yeah, so if you were saying 30 kilohertz, it can receive 30,000 triggers per second.
Okay.
So if you've got, for example, products going down a production line, and those products are at 30 hertz, let's say, what that means is that if you're looking at the same position all the time, 30 products are passing that point every second. So yeah, like I say, 30 kilohertz is quite a lot. But yeah, it depends on your application, I suppose, as to what's big and what's small.
I feel like food and bev would get there. Yeah, I was
Absolutely.
trying
Yeah.
to go
Printing's
as
another
fast,
one.
Yeah.
Yeah, printing we see very high rates because it's all sort of prefixed. So yeah, that's another very high speed application.
Okay. Thanks for the explanation. 15-year-old Emily would have loved to have you as her high school physics tutor.
I hope your high school physics teacher sees this and gets like offended. I did a great job.
Yeah, thanks very much, Mr. Dunn. I appreciate it.
All right, perfect. In that case, are we ready to go to the next scenario?
Yeah.
All right. In this one, a customer wants to trigger their lights based on encoder signals. I don't know what that means. I'm just reading the script. But they don't have a PLC to connect to. And can the controllers be triggered by an encoder?
Yeah, so some yes, most no. So we do actually have a specific timing controller that can take those trigger signals, or those encoder signals, sorry, and convert them to trigger signals that we're used to. So as you said, you didn't know what encoder signals were. I'll do a very quick explanation on that for you. Stop me if you've heard this one before. So if you've got for example, production line running along, you might want to know exactly what position that's in at all times. And the way you do that is using an encoder. So that encoder basically generates pulses at known points of rotation around a cylinder. And if you know a little bit about the geometry of your application, you can say one encoder pulse means that I have traveled exactly, let's use a big number, 1 millimeter. That would be quite a low resolution encoder. But yeah, that's the general idea. So we can say, if you've got encoder signals coming in to trigger the lights, it means that every time the belt has moved a certain distance, you want the lights to trigger. And yeah, we have something called a CC320 is our timing and logic controller that can take that encoder input, and it can be 1 wire or 2 wire. So that's just position or direction and position. And we can convert that into trigger signals and use that to trigger different things. That could be lights, that could be camera, anything that's capable of taking, again, that logic level trigger signal.
Okay. So then does the CC320 have the same, like ability to control the light, but also take the trigger signal, or like how does it differ from just your standard controller?
So the CC320 is just a timing controller. It doesn't have the capacity to drive LED lights with the current that they need. The current on the CC320 outputs is like really low. It's something like 50 milliamps. The main thing it's doing is changing the voltage on that signal line. We do have some controllers, such as the RT-CC420, imaginatively named because it's sort of the child of an RT controller and a CC controller. So losing the name. But that one has outputs that are designed for lights and also sort of digital logic level outputs that work in the same way as CC320 would. And that controller can be really useful because it can, at the same time as triggering lights, it could also tell a camera to come on at the right point at the same time as taking in that encoder signal. And you can have a one-box solution to a single cell in your production line. Again, without that PLC, if you're particularly averse to them for some reason, or if the customer decides they don't want one, a CC320 or an RTCC can solve a lot of problems.
So the CC320 can also receive the signal and trigger the camera?
Yep,
Okay.
yeah, exactly. It's not only capable of taking encoder signals, it can take up to 8 sort of logic level signals again, and then do some clever wizardry on those and say you could have, for example, a good one might be a count where you say every 10 signals I get from here, it would be a divide those down and give me 1 output on this channel and 2 outputs of the burst on that channel. And you can do all sorts of clever sort of things with them. I will admit they're not the most straightforward to configure, but when you get your head around how they think, they are really powerful tools.
I feel like what I've heard is like people, when they like them, they love them. It's like the vibe I've gotten
exactly.
from it.
Yeah, and often they don't like them when they first come across them, and it takes them a while to sort of warm up to them.
Right. So you would use the CC320 with just any other Gardasoft controller?
Yeah, exactly that. So if you wanted to take a trigger signal and you you would need you could do a CC320 and another lighting controller, and combine the two, and you'd be triggering the lighting controller from the CC320, which would be taking its signals from other sensors like maybe a light gate and the encoder, and you could work out sort of what's going on
It's
there.
a light gate.
And a light gate is pretty much just a saw that hand going up. I knew the question that was coming.
Like Lindsay's always saying, I know more than I give myself credit for, but this time when I say I don't know anything, I really mean it. I really mean it, Lindsay.
Controllers we don't talk about them much, so it's fair.
We don't talk about controllers. It's fine, don't worry about it. So a light gate is pretty much just a sensor. It's kind of, there's a few different ways to achieve it, but one might be that you've got a laser and a photodiode, and it just senses when that laser beam basically is cut. So when something goes through that light gate, it will change the signal level in the sensor, and the output will change. So that we could use that, for example, to trigger things in our CC320 or in our lighting controller if the signal voltage levels were right. And yeah, it would be sort of normally low when the gate is not broken, and then when something goes through and breaks that signal, it will change the output, and then we know that something has arrived at that gate, basically, that we know exactly what position it's at.
So you have to use that type of sensor that, shoots like a beam out, and then once something crosses it, like it has to be that type of sensor, because I know there's different types out there.
Yeah. We could use any sensor, really. Any sensor that gives us a logic level output, sort of like 0 volt, 3 volt, or something like that. It doesn't have to be a light gate. It's just an example that I came up with. We could, all sorts of things. We could be using a laser distance sensor, for example. We could be using, I think of other ones now. We could be using just a photodiode and a light sensor. It could be all sorts of different things that would give us that output that we need.
It also doesn't have to be a sensor, right? Like PLC or something like that could send it to.
Yeah, exactly.
I mean,
that.
you wouldn't
Yeah,
use the CC320 with the PLC, but right, you just have a
nothing
PLC,
to stop you.
Would you need it though?
I won't stop you using one. No, if you've got a PLC already, if you've got a PLC already, you likely don't need a CC320. But you can still buy one. I'm not going to stop you. That's the sales side of my job coming out.
Make it rain.
But you would at least tell them they don't need it. You won't stop them, but you would say you don't need this. Because we love it. We love an honest salesman, you know.
Absolutely. Yeah. I'm not going to sell you something you don't need. But a PLC is usually, depending on the one you've got, is very capable of giving that sort of logic level signal that you need, either to trigger a CC220 or to trigger a normal lighting controller. So those can also do the triggering just fine.
Kind of pivoting a little bit, just to clarify and kind of like what the controllers do and when you need the CC320. If you wanted to sequence your light, whether you're doing like, shape from shading or whatever, or some type of computational imaging, or just doing, 2 different lights on, whatever, do you have to have a CC320 or will the controllers do that?
You don't necessarily have to have a CC320. It depends on exactly what your application is. Our controllers, for example, are capable of having sort of individual triggers for every channel. So if we take an RP4, for example, that has 4 trigger inputs that you can use separately. And you can configure the controller so that any combination of channels is looking at any individual trigger signal. So you could have all 4 channels triggering off input 1, or you could have inputs 1 or channels 1 and 2 triggering off input 1, and then 3 and 4 are on separate triggers. So there's all sorts of different things you can do there. The other thing you can configure separately in the channels is their pulse or their sort of delay. So you can say after, say, 2 milliseconds, I want to trigger channel 1 on this trigger, and then after 5 milliseconds, I want to trigger channel 2, and then after 10 milliseconds, I want to trigger 3 and 4 at the same time. And you could do all of that off trigger 1 with just one trigger signal, and you'd get sort of a sequence come out of that. We also, just to complicate things, have a couple of sort of special firmwares on some of our controllers that will take sequencing to a whole other level and do some even more clever things, where you can go through different modes where you vary the pulse width on every channel each time a trigger signal is received. Or you can do the same thing with the current that's being sent as well, if you want to do it in the current domain rather than time domain. But we won't go into that in too much detail. But yeah, like I say, you don't need a CC320 to do some of the basic sequencing things. It's only where you start wanting to get a little bit more complicated with exactly what you need that you might want to start considering a 320.
Okay. Great. That
covers
think
those
that's all.
3 scenarios. Yeah. Again, not super expert on the application stuff, but hopefully those were, things that some of our listeners encounter out in the wild, and now you have a solution, or at least you know who to talk to if you need help on your solution. So thanks, Max, so much for joining us today. It was, for our history making episode, it was a really good one.
Yeah.
It lived up to the hype.
I'm glad to hear it. Thanks very much for having me, guys. It's been really nice being on.
Yeah, definitely. So promotions that we need to, share at the end. We have our next technical roundtable coming on April 30th in Rochester, New York, and Max may be able to join in on that one. Fingers crossed.
Yeah, I want to be there for that one. All things going well. I'm hoping to book my flights this week.
Yeah. So if you want some to really dig into some of the stuff we talked about today, if you need a high school physics tutor
if you're a glutton for punishment and you want to talk about controllers, come and find me.
Exactly. Then again, we'll be at Automate in June, and I think all Gardasoft members attending is TBD, but we will have a Gardasoft demo there, and at least Max, you'll be there as well.
No, Max had a family vacation.
Oh, right.
Yeah, got a family vacation booked. Someone didn't tell Automate when they booked their time slot this year.
Unbelievable.
That I already had a holiday booked at that point, and I can't change it.
Yeah,
so
I think you should prioritize Automate. Who needs vacation? Honestly.
Well, I see it as their loss, to be honest.
Yeah, so I guess definitely come to our roundtable if you want to meet Max, and Automate, up to you. We'll have...
There will be a Gardasoft.
Max will be there, so don't bother going to Automate.
Yeah, we will have a Gardasoft demo, though, so we're excited to show that. And yeah, so thank you for everyone for listening. If you learned something about machine vision lighting control today, I definitely did. Please give this video a like and subscribe to our channel. And you can follow CCSA on LinkedIn. You can also follow me and Lindsay, or connect with us and connect with Max on there as well. And yeah, feel free to send us your questions or, topic ideas, maybe future guest ideas, suggestions. Max already set a really high bar, so you need to bring your A game when recommending somebody. But we definitely love to hear it so that we can, make this as valuable as possible for our listeners. So once again, thanks for listening, and thank you, Max, for joining us.
Thank you, guys.
Thank you, Max.
Bye.